Okay, so we're going to review how to solve for equations. All of the problems I have are from the exit ticket on Quizzes. So if you haven't done them yet, this is a great chance to make sure you know how to do this. If you already have done some of these and you're like, I feel really confident, feel free to skip ahead. This is not mandatory to watch. It's just helpful, especially if you haven't been able to go on to the live classes or office hours. Okay, so let's review this first one. When I think about solving these, I know that my first step includes some sort of inverse operation. So it's going to be something where I'm doing an inverse operation. All right, so when I think about operations, I also know if I were to solve an expression, PEMDAS reminds me of the order that we usually solve in. Now, this doesn't always tell us all the little details, but it will tell us the main ideas. So usually I solve the down, so starting with parentheses and then exponents, multiply, divide, add, subtract. However, inverse means the opposite. So we're actually going to figure out ways to go from adding and subtracting to multiplying and dividing, and then deal with these if there are any, but in this case there are not. Okay, so I have two variables, but I'm going to ask myself, are they the same or are they different? If it's the same variable, I know that I'm going to eventually just solve for x. So x equals something is what my final answer needs to look like. Now I just need to make sure to use one of the strategies we've learned in class before to get x all by itself, without any coefficient, without any other number or term getting in the way. So I'm going to make sure to draw my line down the middle, and that keeps it balanced. Whatever operation I do on the left side, I've got to make sure to do on the right side. My first step, I want to get the x's together, so on the same side of the equal sign. So this x can stay there, and I'm going to use the box method. This still uses inverse operations, but the box method will just keep it a little bit more organized for me. In this negative 2x, I cannot forget about this negative sign in front of the 2x. It is attached. Even though we say subtract, subtract, negative, same thing. So I got to make sure that when I organize the terms, that if it crosses over this balance line or the equal sign, that the inverse happens. So if it's a positive, it changes to a negative. If it's a negative, it changes into a positive term. So now it's a positive 2x. And then I'm going to do the same thing over here. The 7, there's no variable attached, it's just a term by itself. So a constant is what we would call it. And this negative 5. Whoop. It crosses over the equal sign, so I know it's going to be a positive 5. What we just did there was reordering our terms. So in some way, if you can organize it to say reorganize terms or combine like terms, something along those lines is what our very first step would be. Just to solve this, just so you know how to, it's 3x. There's an invisible 1 in front of the x when it's by itself. So x plus 2x is 3x equals 7 plus 5, I know that is 12. When a 3 is attached to the x, we know that's multiply. And the opposite of multiplication is division. So divide by 3, x equals 12 divided by 3, which is 4. In the background, if you can hear my cat meowing, he's super weird. All right, let's go ahead and quickly I'm going to solve this one. You can pause it here if you're trying to really learn this and teach yourself, and try to solve it on your own before clicking play again and seeing if you get the same answer as me. That's going to be like the best strategy for you, and I know a lot of high school teachers will have you do similar tasks like that. All right, so my equal sign, I know it's going to be balanced. I'm going to do this problem in the kind of more traditional way, so not using the box method. The box method is up here and it keeps things organized. This one I'm just going to use inverse operations. So I'm going to add 4 because I'm trying to get it away from this n. That eventually is going to be my final answer. N equals something. Add 4 to both sides. It cancels it out here. Negative 4 and positive 4 cancels or undoes it. So all I'm left is 3n. Negative 2 plus 4. You know that is a positive 2 because the positive 4 is the larger number, and we figure out the difference. 2 plus 2n. I still have to get this 2n onto the same side of the equal sign as the other one. So I'm going to do the opposite, which is negative 2n. Every action has to be done on both sides to stay balanced. We are left with 1n equals 2, otherwise known as just n by itself. N equals 2. And there we have it, our final answer. All right, so on the 29th, so this is the one that was due yesterday, but you might not have done it yet. I'd rather you still get credit and do it late than not do it at all. And it also will just help your brain when it gets harder on the next ones, like today's and tomorrow's. So again, sometimes we have to just keep the main idea in mind, even if you might solve it in a different way than I would. So on this one, we see that there's a parentheses, and we see that there's a number in front of the parentheses. There's 2 ways that we can do this. So let's do the first way. Yeah, let's do this by distributing. And then on the next problem, we'll solve it in a different way that I find a little easier. But everyone has their preferences. So to distribute, we know that every single term inside of this parentheses is going to get multiplied by the number outside of the parentheses. When we do that, it's going to be 20 minus 4x. The 8 stays the same because it has nothing to do with the parentheses over here. Now it's just simply, we're going to reorganize the terms. So reorganize or move the terms as our next step to get it very close, but one step away from solving just for x. So I'm going to keep my x on the left side here and everything attached to it, so this negative 4. And I'm going to get rid of this 20. It's a positive 20, so I subtract 20 on both sides. I rewrite negative 4x, nothing happened to him. And now I know, okay, what is 8 minus 20? If the 8 is positive and the 20 is negative, I know I'm going to find the difference of them and keep the sign of the larger number. 20 is the larger number, so it's going to be a negative. And I have to figure out what's the difference between 8 and 20. So 20 minus 8 is 12. Negative 12. The last thing to do is I need to divide by the number in front of x, including the sign. Negative 12 divided by negative 4 is 3. So x equals 3. All right, let's do 2 more problems, and then I'll let you just contact me if you need any extra help. At the end of this, I'll share you my email in case on Google Classroom, my email and phone number in case you don't already have it, so that you can reach out if you need any extra help. All right, so in this one, I see kind of a combination of things happening. The variable v is in multiple locations, and there's a distributive property. However, I can think about this in a way that will make it easier if I do one step first. Whatever numbers we're dealing with here, I want us just to kind of ignore what's in the parentheses right now. We'll come back to that in a second. I'll erase that scribble. But if these were numbers and I wanted to simplify this, as long as I do the same action to every term, or at least to both sides, it will still stay equivalent or equal. And that's all that matters. So what will make this easier if there is a greatest common factor that I can divide them all by, just like with fractions. So just like we know 4 out of 8 I can divide them both by 4 over 4, and it equals 1/2. This is simpler to work with. That's all we're going to do. So the greatest common factor between 8, 4, and 8 is 4. So divide all of them by 4, which we will get 2v minus 2, and then 8 divided by 4 is 2. Wait, what about what was inside the parentheses? Great. We're going to rewrite the parentheses down here now. Oops, and I made a little mistake. That shouldn't be 2, that should be 1. Make sure you don't forget about this subtraction sign. It's very easy to forget about it and put +1 and then forget about your parentheses, but don't do that because it will get the wrong answer for you. So we have to distribute this -1 to each of these, which basically just means we're distributing the negative. So it's 2v minus b minus 8 equals 2. Then again, you're just moving the terms around just like we've done. If you've noticed, that was always a step we always do. 2v minus 1b, because a variable by itself, there's an imaginary or invisible 1 in front of it. So v minus 8 equals 2. The last step would be to add the 8 to get rid of it. V equals 10. Okay. All right, let's do this last problem. Yeah, that's just the same thing we've been doing on the 30th, but this one on number 11. All right, so there's a fraction, and I know a lot of the times when we see fractions, we freak out, but this one is not too bad. There's a very simple step if we think about it in terms of operations. The fraction bar, so like 1/2, this fraction bar always means the same operation. It means division. So I know that that really just means 1 divided by 2, which is true. If I say 1 divided by 2, I get 0.5, and that's the same as 1/2. So really, this whole thing is just saying 2x minus 3 divided by 4 equals 9. So it's super easy to say, okay, the inverse operation then, I'm just going to multiply by 4. I'm going to do that to both sides to keep it balanced. Same thing as always. All right, if I multiply by 4, it cancels out on this side. So I just rewrite those terms. And then I simplify. What is 9 times 4? 36. I add 3. And I'm just slowly getting x by itself, whatever steps I need to do to get x all by itself. To cancel out other terms, simplify, and then do it again. Then I know that 2 times x is what it means when there's a number or the coefficient in front of x. Divide by 2 on both sides. X is equal to, what is 39 divided by 2? I know 40 divided by 2 is 20, so it's going to be slightly less than 20. It's going to be a 0.5, so I know it's going to be 19.5. Anything that you're doing on these, make sure you're just taking your time and writing it out on paper. If you're trying to do it in your head, I can't even do that in my head, and I've been doing this for a long time. So get a piece of paper. I don't care if it's strap or if you do it all nice and neat, but don't try and do all of this in your head. It'll make it too difficult. If you can tell, on quizzes where your eggs tickets are, I can see how long you're taking on certain problems, and it is driving me crazy when I see it say 6 seconds. And these are all really great students, None of them got it right because they're just guessing, it seems like. They didn't try to do their problem. Instead, they just clicked something. And obviously, no one has gotten it right on this problem. However, I doubt anybody in 2 seconds really did it. So just give yourself some time. There's 15 minutes per problem. You have unlimited time, basically. Really put some effort, write it down, Google it up. I'm okay with that. Just do what you can to make sure you're getting a good grade for yourself. We have a few weeks left, and I'm here to help you if you need me. My email and phone number on Google Classroom if you need to reach out.